Hey everybody out there, this is 9.1 Algebra 1. 70 lessons in this suite. Email me if you're interested in PowerPoints, videos, or worksheets. 9.1 Graph y equals ax squared plus c. So we're going to get into some quadratics here for Algebra 1. Here's your bell work, teachers, as your students come into your classroom. Or homeschoolers, it's a good warm-up for you. And everybody else, good too for you as well. 9.1, graph y equals ax squared plus c. Before you graph linear and exponentials, you will graph simple quadratics. So you can solve a problem involving an antennae. Here's your antennae here. That's giving it away, huh? Radio telescopes is what they look like. A quadratic function is a nonlinear that can be written in, here's the standard form for a quadratic where a does not equal 0. So it's got a parabola, it's got a U-shaped graph called a parabola. In this lesson you will graph quadratic functions where b equals 0. So up here where b equals 0. Concept here, parent quadratic function. The most basic quadratic function in the family of quadratics is called the parent quadratic, y equals x squared. Here's a y equals x squared graph here. The lowest or highest point on a parabola is the vertex. Here's the vertex of the graph of y equals x squared is 0, 0. If the vertex is here at the origin, right there, the line that passes through the vertex and divides the parabola into two symmetric parts is called the axis of symmetry, right here. The axis of symmetry for the graph of y equals x squared is the y-axis. X equals 0, so here's your axis of symmetry. First example here, graph y equals ax squared where a is greater than 1. So we have a positive here. Make a table of values. Here's your table of values for y equals 3x squared. Plot the points from the table. Here is your graph here of y equals 3x squared is your red line here. It's steeper because this coefficient here will make your parabola what they call compress. It'll compress the parabola and make it slope steeper. This is y equals ax, or rather y equals x squared is your blue parabola. Compare the graphs of y equals 3x squared and y equals x squared. We're going to compare them again. Here they are. Both graphs open up because your coefficients here are positive. The graph of y equals, now they call it narrower, but it's steeper, it's compressed, it's narrower, same thing. Then the graph of y equals x squared. Because the graph of y equals 3x squared is a vertical stretch, they call it a vertical stretch too, by a factor of 3 of the graph of y equals x squared. So they call this a vertical stretch too, okay? Here's our first guided practice, graph the function. Compare the graph of our parent quadratic, y equals x squared, y equals 8x squared. And then down here, students, this is for you. I will let you use a graphing calculator with this if you wish. Either way, compare the graph y equals x squared to y equals 8x squared. So here's your comparison. Here's your y equals 8x squared. It's much steeper or stretch, vertical stretch of the y equals x squared graph. And then here's the table of values for that. I put in a calculator shot here, y equals x squared and y equals 8x squared down here, y2 on your TI-84. So here are the graphs on a TI. Here's your y equals 8x squared, this line here. Out here is y equals x squared. Okay, example 2, y equals ax squared, where a is less than 1. So this here will be less than 1. The absolute value will be less than 1. What does that do to the graph? So we have a negative 1/4 x squared. Compare the graph with y equals x squared. Here's the table of values now for this quadratic here. Y equals negative 1/4 x squared. When x equals -4, y equals -4. Here's the graphs now. Y equals negative. If your coefficient is negative, your parabola will point down like this. Here's your parent function up here. Draw a smooth curve through the points. Compare the graphs of y equals negative 1/4 x squared and y equals x squared. Both graphs have the same vertex and the same axis of symmetry. Their axis of symmetry is here, is the y-axis, x equals 0. This is because the graph of y equals negative 1/4 x squared is a vertical shrink by a factor of 1/4, with a reflection in the x-axis of the graph of y equals x squared. So the negative here points the parabola down. It flattens the curve. They call that a vertical shrink. I don't know why, but it flattens the curve out. The curve is more open. The parabola is more open rather than this, because this has a coefficient. It makes the slope of the parabola steeper, whereas if it's less than 1, it flattens out the curve. And then for guided practice number 3, graph the function here. So again, I'll let you use a graphing calculator, and down here use a graphing calculator, or if you want to do it by hand, you can do it by hand. Y equals 2/3 x squared. Here is the table for this quadratic here. So you can plug these values into your table. And then here's the comparison here. Y equals 2/3 x squared, and then y equals x squared. So 2/3 x squared is what this table here, the values here in this table on your calculator, are the table of values for this quadratic. There's the table. Then here is the curve here. Here's the parabola for y equals 2/3 x squared. It's flattened out a little. The parent function y equals x squared is here. It is a little bit steeper than your y equals 2/3 x squared, which is here. Then here is the table again. Here is the table for y equals x squared. This is the parent function, the values for the parent function here. Then here's for 2/3 x squared, or over here, the values are over here for the table. And then here's the plot on your graphing calculator here of these two parabolas. Then here's another graphic of these curves. Both graphs open up, have the same vertex, and have the same axis of symmetry. Here's your axis of symmetry again, where x equals 0. The graph of 2/3 x squared is wider because of the vertical shrink. So 2/3 x squared is out here. It flattens out. They call that a vertical shrink. I guess it falls back a little. I guess maybe that's where they get it. It shrinks. I don't know. You shrink to me it would be steeper. Oh, whatever. Is wider because of the vertical shrink. Okay. Then we go into example 3 here. Graph y equals x squared plus c. So here we move up. Here's our y-intercept here. When x equals 0, y equals 5. So when x equals 0, y equals 5, that's where your vertex is. Plot the points from the table. So here's your plots here from your table. Draw a smooth curve through the points. We did that here. Compare the graphs of y equals x squared plus 5 and y equals x squared. Both graphs open up because the coefficients here are positive, positive 1, positive 1. However, the vertex of this one is at 0, 5, starts here. And because the graph is a vertical translation of 5 units up of the graph of y equals x squared. Then we have another guided practice here. Here's yours down here, students. Use a graphing calculator or fill the table in by hand. So when x equals 0, y equals 9, we have a what they call a vertical translation. Here's the tables here of your two parabolas. And then here is a graph of it. Y equals x squared plus 9, because of the vertical translation, 9 units up. And here it's how it looks on a calculator. Into homework, copy vocabulary and writing. You've seen all this before, students. Match the quadratic with its function here. Graph these quadratics, more graphing. We covered that in the classwork. You'll be able to do that, no problem. More graphing of quadratics. Here you only have 2, so this is like a spare grid out here. And then that was 9.1, Algebra 1. Thank you very much.